This is going to be a quick video that walks through how to correctly complete the sixth slide problem in the Desmos exploration on implicit differentiation. I noticed a number of people managed to get the correct derivative, but then didn't know what to do with the next steps. So I was going to go through just starting from the beginning, show how to find the derivative equation, and then use that to get the tangent line equation. So we have this relationship, 2xy squared equals x plus y cubed minus 2. It's not a function, as you can see in the graph. It has multiple outputs for any given input. But we can use implicit differentiation to find the derivative equation. Now, if we go on the left side here, we have 2x times y squared. And you'll notice I put in parentheses here because often it makes it easier when I'm looking at product rule, because I can sort of be like, okay, there's my 2x is one of my terms and it's being multiplied with y squared. So when I use product rule, the derivative of 2x is 2. Then times y squared. Then it's 2x. I might write that up here. 2x times 2y, y prime, because whenever we take the derivative of y, we have to imagine the chain rules going on there. And that 2x times 2y, y prime can be simplified to 4xy, y prime. And then we do just straight up power rule on the other side for our derivatives. We have derivative of x is 1 plus derivative of y cubed was 3y squared, and then times y prime, because again, chain rule. Now, we want to get our y prime terms on the same side of the equals and the non-y prime terms all on the same side. So I subtracted 1 over to the left side, and then I subtracted the 4xy y prime term over to the right side. It really doesn't matter which way you solve, which way you move the terms, as long as you've split the y prime terms away from all the non-y prime terms. And this enables us to factor out that y prime. And so then we can divide by the 3y squared minus 4xy, and we get the 2y squared minus 1 all over 3y squared minus 4xy. Now, if you moved terms to the opposite side as I did, so you moved the y prime to the left side and the non-y prime terms to the right side, you would have wound up with the derivative written sort of basically with all the signs opposite. Either derivative is correct, and that would basically, this equation would give us the slope given any point on our graph. Well, we were given a point on our graph. We were specifically given the point 2, 4. So if I want to find write a tangent line to that point, I need to figure out what the slope is at that point. So that basically means I needed to plug 2 in for x and 4 in for y into this derivative equation. And when I do that, I end up with 31/16 as my slope. And then it's just point slope form. There's my slope. Here's my point. And ta-da! If I go over to my graph here, I'll notice, there's my tangent line. It touches at the point. It doesn't matter that it passes through at a, sort of another section of the graph. I'm really just focused on what's it doing right around that blue point, and yep, it's a tangent line. So I did it correctly. I basically would repeat that process in blue for the other point at -3, -1, and get a new slope, and then a new tangent line. I hope walking through this problem helps you a little bit. The other problem on the next slide was similar. Yes, there was some trig involved, but basically the same sort of process. This is a skill that you will need to be prepared to deal with for your second exam. So hopefully this video helped you a little.